In this question, we're going to deal with the sugar cell. So it says a sugar cell is an exciting fuel cell that is in the early ages of development. The sugar cell simulates the transfer of electrons in cellular respiration using enzymes to catalyze the reaction, freeing electrons. So we get the reaction here, and I've assigned oxidation numbers to everything. It says how many moles of electrons are transferred per mole of glucose. So I can see that carbon is going from 0 to plus 4, so it's losing electrons, oxidizing, it's the reducing agent, and my oxygen is going to become, is gaining electrons, reduced, it's the oxidizing agent. Well, if I'm going from an oxidation number of 0 to plus 4, that's 4 electrons per carbon, but this has, glucose has 6 carbons. So for C6H12O6 is going to be 24 electrons. We've got 2 electrons per oxygen, 4 electrons per oxygen molecule. So lowest common multiple for 4 and 24 is 24. So this is going to be times 6, and this is times 1. Well, this means that this is the number of electrons for 1 mole of glucose reacting here. So the mole of electrons transferred is 24. It says, what role does oxygen play in the sugar cell? Well, the oxygen is the oxidizing agent. It is reduced. And it says, what environmental benefits could a sugar cell have over a lithium ion cell? Now, lithium ion cells involve mining minerals. They're fairly toxic once they are done. And so we're really talking about reducing the amount of energy to make it, because this is made out of obviously a sugar water solution. And so it's much lower energy to get the minerals to be able to do this than it would be for a lithium ion cell. It's also much easier to clean up after the fact. That's it. Then it says, what mass of sugar is required to make 2 amps of electric current for 35 minutes? So 2 amps for 35 minutes is going to allow me to get the number of moles of electrons. So it's 2.0 amp, and the time is 35 minutes. So I can make that into seconds by taking 60 seconds per 1 minute. And this is going to allow me to determine that I've got 2100 seconds that are being the duration. So the number of moles of electrons equals current times time over Faraday's constant. So it's going to be 2.0 amp divided, or times 2100 seconds divided by 9.65 times 10 to the 4 coulomb per mole of electrons. And so I will calculate what that is, and we end up getting 0.0435 mole of electron. The number of moles of sugar, though, is related to the Stoich ratio. So for one of these, it's 24 electrons. So it'll be 0.0435 mole times, that's of electron, so 24 electrons for 1 sugar. So I'm going to find out that this is 0.00181 mole of sugar. But the mass of sugar is going to be the number of moles times the molar mass, so I'm going to get that value, and I'm going to multiply it by the molar mass of sugar. And the molar mass of sugar is a pretty big number. I'm not going to show you how you calculate it. I trust you can do that by now. But it's 180.18 gram per mole. So this is going to end up 0.327 grams. I guess I only have 2 sig digs here, so really I should say 0.33 grams of sugar will give me, will be required to make 2 amps at 35 minutes duration. Hopefully that helps you figure this all out.